Welcome back to the deep dive. Today we are really opening the hood on, well, the operating system that pretty much powers the internet, GNU Linux.
hmm
So if you manage servers, maybe you're tackling a big certification like the RHCSA, or even if you just want to move beyond basic shell scripting, get into proper system administration,
Yeah,
then this deep dive is definitely your shortcut.
absolutely. This is foundational stuff.
Our mission today is basically to dissect and really conquer the systemctl command. It's the single essential tool for modern service management. No getting around it.
Nope, it's central.
We're working through a pretty comprehensive guide here. Covers the history, the core ideas, and crucially the practical side, like setting up a real web server.
Right, the hands-on part.
So by the end of this chat, you should understand not just what commands to run, but really why they work. That gives you, confident control over any system-based machine.
Yeah, and it's interesting because to really get systemctl, you first have to grasp the huge shift in how Linux boots up and runs processes now. Before system came along, we were pretty much all using SysVinit. And while that older system had some critical limitations.
Okay, let's unpack that historical baggage, as you say.
Yeah.
When we talk SysVinit, what was the main architectural flaw, the thing that slowed down boots and made management tricky?
Oh, it was fundamentally sequential. Just think of a long line of dominoes, right?
Okay.
When the system started, it had to run script after script after script, one by one. If one service took ages to start or maybe waited for the network.
Everything else just waited.
Exactly. The whole boot process just bottlenecked. It was, frankly, cumbersome. You had these complex shell scripts for really basic tasks, and managing dependencies felt like manually untangling wires.
Yeah, I remember those days.
Plus, it used those kind of clunky, sometimes ambiguous run levels for system states.
Right, run levels. So, okay, sequential bottleneck. Then around 2010, System arrives with a totally different philosophy. If SysVinit was sequential, what was the key shift System made for that massive speed boost?
Aggressive parallelization, that's the core idea. And deep kernel integration.
Parallelization.
System basically tossed out the old sequential scripts.
Yeah.
Instead, it uses these declarative unit files. They explicitly state dependencies, what needs what.
Ah, so it knows the map beforehand.
Precisely. Which allows it to launch services simultaneously whenever possible.
Yeah.
That dramatically cuts boot times. And here's a key technical bit. Systemed heavily uses kernel features like control groups, C groups.
C groups, right. I've heard that term.
They meticulously track every single child process spawned by a service.
Ah, okay. So that's why System is so good at cleaning up. It knows exactly which processes belong to, say, the web server, guaranteeing a clean stop, not like the old hit or miss way.
Exactly right. No more orphan processes hanging around. And systemctl, well, that's simply the command line tool we use to talk to this powerful, centralized systemed engine.
Got it. So systemed is the manager, the architecture. What are the actual building blocks it manages? Units, you said. What exactly is a systemed unit?
A unit is basically just a configuration file. Usually uses a simple INI style format,
Right.
with sections and square brackets.
Okay.
And it defines and describes a specific resource that system needs to manage. Pretty much every single thing system controls, a service, a device, a mount point, is defined by one of these unit files.
Okay. Makes sense. And as admins, we mostly deal with what, 4 fundamental types? The most common, I guess, is the .service unit.
Yeah, absolutely. That manages your typical system daemon, a database, a web server, SSH daemon, things like that.
But the other 3 really show off systems sophistication, right? We have .target units. You mentioned they replace run levels.
Yeah, think of them as synchronization points. They group units together to achieve a certain system state.
Yeah.
Like multi-user.target is your standard server state. They're much more flexible than run levels ever were.
Okay. And then there's efficiency. The .socket unit. That sounds interesting.
Oh, socket units are key for that parallelization and efficiency we talked about. It enables something called socket activation.
Socket activation, meaning?
Meaning systemed itself can listen on a network port, say port 80 for a web server, on behalf of the actual service. And it only actually launches the web server process when a connection comes in on that socket.
So the service isn't running, using up memory, unless it's actually needed.
Exactly. It dramatically conserves resources. Brilliant for things that aren't constantly busy.
Wow, okay. That's clever. And the 4th type, .timer units. You mentioned they're like a modern cron.
Pretty much, yeah.
Yeah.
A modern integrated replacement for the traditional cron daemon.
So quick question then. If I'm a sysadmin and my cron jobs are working fine, Why should I bother switching to systemd.timer units? What's the real benefit there?
Well, it boils down to integration and reliability. Timer units aren't separate. They're part of the main system management framework.
Okay.
That means they respect dependencies, they're tracked by those kickers we mentioned, logs go to the central journal, and you can view, start, stop them just like any other service unit using systemd.
Ah, so easier to manage and diagnose.
Way easier.
Yeah.
They're just much more robust and transparent than cron jobs, which often run in this weird, isolated environment that can be a pain to debug. It's really a more professional approach.
Good point on diagnostics. Okay, let's get into the commands you absolutely need day to day. We know the basics, start and stop.
Right.
But let's talk production. You need to apply a config change to a live web server. Is systemctl restart the way to go? Or is there a, safer option?
That's a really vital distinction for production systems. Systemctl restart is, well, it's the blunt hammer.
Laugh slightly.
It does a full stop, then a full start. Guarantees your changes are loaded, yes, but you absolutely get a brief moment of downtime. Connections will drop.
Not ideal. So the graceful approach.
The graceful approach is systemctl reload.
Yeah.
Now, this command tells the service to try and reread its configuration without shutting down the main process.
If the service supports it.
Crucially, if the service supports it. Many common ones do, like in Jenks, Apache, Postfix. You apply the changes, run reload, and hopefully zero interruption for users. You absolutely need to know if your specific service supports reload.
Right. Okay. So we issue command start, stop, reload, whatever. We need feedback now. Diagnostics. The indispensable tool seems to be systemctl status. What should you immediately look for in that output?
Oh, the status output is packed with gold. It leverages the system journal automatically. First thing you see is the unit loaded correctly. Did system find the file? Then it's active state. Is it active running, inactive dead, or, oh, failed? That's critical. You'll also see the main PID, the main process ID.
Okay.
And super helpfully, the most recent log entries specifically from that service pulled right from the journal. It's your instant window into what's happening without digging through separate log files.
Fantastic. Okay, status checks the current session, but what about persistence? If I start my web server now, it's gone after a reboot, right? How do we make it stick?
Right. That's the classic runtime versus boot time distinction.
Yeah.
Start is runtime. For boot time, you need enable.
Enable.
Systemctl enable httpd.service, for example. What that actually does under the hood is create a symbolic link in the right system directory structure.
Yeah. Okay.
That link tells system, when you reach the default target state during boot, make sure the service is running. To reverse it, naturally, it's systemctl disable. That just removes the link.
And there's a quick check command, too. Is enabled.
Yep, systemctl is enabled httpd.service. It'll just tell you enabled, disabled, or sometimes static for units that can't be enabled or disabled, but might be pulled in by dependencies.
Okay. Now, for the experienced sysadmin, if I can just disable a service, why would I ever need the nuclear option, as our source calls it, masking? When is systemctl mask actually necessary in production?
Yeah, nuclear option is about right. Masking is for when you are absolutely positively sure this service should never run. Not manually, and crucially, not even if another service tries to start it as a dependency.
The dependency part is key.
That's the key difference from disable.
Right.
Masking works by creating a symlink, but it points the unit file directly to devnull.
To nothing.
To nothingness. So if anything, a user typing start or another unit listing it as wants or requires tries to start it, system hits a wall, the config file is effectively gone. It's the ultimate lockdown for a service. And you have to explicitly unmask it later.
Got it. Very clear distinction. Okay, let's shift focus slightly to the overall system state. We talked about targets replacing run levels. What are the common states or targets we typically switch between?
Well, the main two you'll encounter are multi-user.target. That's your standard server command line interface environment, no GUI.
Right.
And then graphical.target, which adds all the services needed for a graphical desktop environment. You can see your default boot target with systemctl get default.
And change it with set default.
Exactly.
Yeah.
Systemctl set default multi-user.target makes it boot a command line next time.
But here's the really powerful move, I think. Changing the entire system state right now without even rebooting. That's the isolate command, isn't it?
Yes. System covering isolate target name. For example, systemctl isolate rescue.target drops you into a minimal single user mode for emergency repairs.
Wow.
It's powerful because system figures out all the dependencies, it cleanly stops services not needed by the new target, and starts any that are needed.
Yeah.
It's a fast, reliable way to change the server's operational mode on the fly. something that was often messy or just required a full reboot back in the SysVinit days.
Much cleaner. Okay, but what if that transition or anything else goes wrong? We need logs. We rely entirely on the integrated logging daemon journal. Since those logs are binary, we can't just cat them. We need this special tool, journal coupler.
That's right. And because journaled is fully integrated with systemed, it knows about all the units. This makes filtering incredibly easy. The simplest, most powerful troubleshooting command is usually filtering by unit.
Like systemctl at djengings.service.
Exactly. That cuts through all the system noise and just shows you the log entries relevant to your Nginx service. Instantly narrows down the problem space.
Makes sense. And what about for real-time issues? Like if a process keeps crashing and restarting?
Then you use the follow flag.
Yeah.
-ff.
Yeah.
Just like tail-f.
Yeah.
So journal pictl-hu and ngx.service will show you new log entries for that service the instant they're written. Essential for live debugging.
Nice.
And beyond that, the filtering's just great. Quick diagnosis after a reboot. Use -b. That shows logs only from the current boot.
Oh, that's handy.
Or filter by time since 5 minutes ago or until 10.00. Honestly, the integrated journal is such a massive improvement over hunting through dozens of scattered text files in varlog.
No kidding. Okay, that brings us nicely to some more advanced, maybe utility commands. What are some quick commands that can save an admin a lot of time?
I really like the quick filters for listing units. If you want to see all installed service unit files and whether they're enabled or disabled, systemctl list unit files type service gives you a great overview.
Okay.
But the real time saver, maybe when you log in first thing Monday morning, is systemctl failed type service.
Instant problem report.
Exactly.
Yeah.
Shows you every service unit that failed to load or start during boot or sense.
Yeah.
Tells you where to start looking immediately.
Very useful. And what if I need to quickly peek inside a unit file, maybe check an environment variable or an exec start line, but I don't want to hunt for the file path?
That's where systemctl shet.service is your friend. It just dumps the contents of the actual unit file system is using directly to your terminal. Super convenient.
It is. But speaking of files, let's talk customization, because this is where a lot of people, especially beginners, make a really critical mistake. Why should you basically never edit the original unit file directly, like the one in userlib's system?
Yeah, this is super important. You avoid editing those files directly because your changes will get wiped out.
Wiped out? How?
The next time you update the package that owns that file, say you run dnf update nginx, the package manager will just overwrite the file in userlib system with the new version from the package. All your careful customizations gone. Poof.
And your service might break silently. Huge operational risk.
Massive risk. Precisely. So professional best practice way is to use systemctl edit unit name. So systemctl edit httpd.service.
Okay, edit. What does that do differently?
This is the crucial part. It doesn't touch the original file. Instead, it safely creates an override file, usually an etc. system httpd.service.doverride.com.
A separate override.
Exactly. System reads both the original file and this override file, and the settings in your override take precedence. Your changes are safe from package updates. They're clearly separated, easy to find and review. It's the clean, safe way.
That makes perfect sense. And related to that, there's daemon reload. When do I need that?
You only need to run systemctl daemon reload if you manually create or modify unit files or configuration files directly on the file system, like placing a new .service file in xsystem system, or maybe editing one of those override files with vim instead of systemctl edit. Systemctl edit actually runs daemon reload for you automatically. But if you do it manually, you must run daemon reload to force system to rescan its configuration directories and pick up your changes. Otherwise, it won't know about them.
Got it.
Yeah.
Systemctl edit handles it. Manual changes need daemon reload. Clear. Okay, let's tie all this theory together with that real-world Nginx scenario from our source material. We're setting up Nginx, say, on a Rocky Linux 9 system.
Right. Pretty standard task. Step 1, obviously, install the package, dnf install Nginx. Easy enough.
Okay, package installed. Now, the unit file exists, but it's disabled and not running that.
Correct. So step 2 is the efficiency move, the shortcut the pros use. Instead of running systemctl enable nginx.service and then systemctl start nginx.service.
We combine them.
We combine them, use the now flag to systemctl enable now nginx.service. That single command tells system, enable this service so it starts on boot and start it immediately in the current session. 2 birds, 1 stone. Very efficient.
Love it. Okay, step 3, verification.
Instant verification. Systemctl status nginx.service. You're looking for 2 key things in the output. Loaded, enabled, and active. Active running. You see both? You're good?
All right, service is running locally, but it's a web server. We need network access. Step 4, firewall.
Yep. critical step. Assuming firewall is running, which is common on Red Hat-based systems like Rocky, you'd use firewall-cmd. Something like firewall cmd add service HTTP permanent. The permanent flag makes the change survive reboots.
And then you have to apply it, right?
Right. The permanent change doesn't take effect immediately. You need firewall cmd reload to make the live firewall rules match the permanent configuration.
Okay. Firewall open. Final check.
Final check, step 5. Just peek at the logs again to be sure. Use that integrated journal. Journal HTL-AGNGANX.service-S5. Just show me the last 5 log lines. You should see entries confirming it started cleanly and is listening on port 80. Confirms everything applied smoothly.
Perfect. Install, enable, and start. Status check, firewall, final log check. Very logical flow.
It becomes second nature once you do it a few times.
So wrapping this all up, what does this mean for you, the listener, the learner? We've really seen that systemctl isn't just, a random collection of commands. It's a predictable, unified, really robust framework for managing modern Linux.
Yeah, for professional work, for certifications, mastering this system isn't really optional anymore. It's mandatory.
And understanding those core concepts, the parallelization, the unit files, the targets, the Moodle groups integration, that's what makes troubleshooting feel intuitive, not like guesswork.
Exactly. You now have the full toolkit, really.
Which leads us nicely to our final thought for you to maybe explore on your own. We've focused heavily on service units today because they're the most common, but the system ecosystem is vast. So maybe your next deep dive could be into how system manages system resources. Consider looking into resource control using slice units. That's getting more advanced.
Yeah, slices are powerful for resource allocation.
Or, for maybe a more immediate practical win, really explore how to create complex, reliable scheduled tasks using the .timer unit type. Think of it as cron on steroids. Fully integrated.
Definitely. Timers are super flexible and much more manageable than cron once you get used to them. A really worthwhile thing to learn.
Lots to explore still.
Always more to learn with Linux. Just keep using that NAF flag on Journal Laughs.
Good advice. All right, see you on the next deep dive.